Gentlemen, welcome to some grade 8 mathematics and probably a new voice. I'm wondering how many of you know who this is. Quick shout out to my class if you do know. Today we're going to be looking at the Cartesian plane, and since you can't fly anywhere right now, let's take this plane to Mathland. For this lesson, I would really recommend that now you pause the video and you go and get a pen or a pencil, a ruler, a notepad. We're going to need all of these today because you're going to be drawing and you're going to be labeling, and so you're going to be doing some exercises while I'm explaining some of these concepts. So pause the video right now and go and fetch your stuff. Okay, as we begin, I think it's important that with all of these, you understand that there's a groundwork of rules that must be applied so that we all speak the same language. And maybe I can equate it as the following. When you play a game of football, if you watch a game of football on the screen, everybody knows the dimensions of the field, and the distance from the one goalkeeper's line to the midfield, to the middle line, is the same distance from the middle line to the next goalkeeper. It would be unfair if we had one team who only played on 25 meters and another team that played on 50 meters. So for our purposes, it's always important that you have equal dimensions. So what you're going to draw always when you're working with Cartesian planes is distances that are equal in the horizontal and the vertical. And so I'm going to explain this perhaps by looking at this grid. If you had a blank piece of paper in front of you, when you set this blank piece of paper up, each distance that travels from each corner must be the same going left to right as it is going up and down. So it's vitally important that when you set up your grid, you measure these properly. So what you're going to do on your piece of paper now is draw a grid. And I'd like your grid to have the following dimensions, please. Your grid has got to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units wide, and 1, 2, 3, 4, 5, 6, 7, 8 units high. Pause this video and set up a grid on your blank paper that looks like the following. Needs to be the same number of units wide and the same number of units high, and each square must be square, so use your ruler to measure it properly. Alright, good. Now that you've drawn this, you need to find the middle of all of these grids, and the middle has a very specific name, and the name we give to the middle is called the origin. We want to try and find the origin. So for us, we're going to count, and we're going to see that, well, if I had 18 going across the top, halfway across for 18 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would need the origin to come down 9 spaces. Let me just change my color to red. Oops, I don't know why I've drawn a line there. Red. So 1, 2, 3, 4, 5, 6, 7, 8, 9 means that my origin is going to be somewhere along this line here. I want to do the same to find it going up and down, a vertical distance. And so my vertical distance, if I have 1, 2, 3, 4, 5, 6, 7, 8 points, I would have to be 4 points up. So we count 1, 2, 3, 4 points up, which means that my origin for this line is going to be along here. Hopefully you're using a ruler. This is not that neat. What we have now done is we have determined where the origin is, and we label the origin in mathematics with the circle. So we tell the reader that this is the origin. That is the place that we're interested in as a reference point. If this was the piano, this would be middle C. If this was the football field, this would be the center line with the center circle. So right in the middle of everything, this is the origin. The next important component we need to speak about so that we all speak the same language is the scale of our drawing. And it's important because we need to have different measurements, and as long as we're all talking about the same scale, we'll be able to interpret this the same way. So from the origin, if you moved 1 unit to the right, we would be able to say that this position is a 0 plus 1, which is a 1. If we moved another unit across, this would be position 2, and 3, and 4, and 5, and 6, and 7, and 8. And this could carry on going indefinitely. We could keep counting. So what we importantly do is we show an arrowhead on that axis because that could go on forever. The same would be true going to the left. This would be -1 because we're going back, -2, -3, -4, -5, -6, -7, minus 8. And could we keep on going forever? Yes, we could. So we need an arrowhead. You've seen this before. What does the structure look like? Yes, the number line. But because we've got this horizontal number line, we need to give it a name. And so what we do is we label our axes. And the third thing I'm going to say to you is we've got to label this axis. The horizontal axis is called the x-axis. And we're looking at x values going left to right. However, we don't just move left to right. We could also label this so that we could move up and down. So if I moved from the origin up one position, I would be able to say that this is a 1, a 2, a 3, and a 4. Again, we could keep counting if we had more space, so we put an arrowhead here. And I could count down. I could say that this is -1, and -2, and -3, and -4. And again, we could keep on going, and because we can keep on going, we put an arrowhead. This is also a number line. This is just a vertical number line. So we have the intersection of two number lines, a horizontal number line and a vertical number line. The horizontal number line we have called x, and the vertical number line we're going to label y. And it's the combination of these two number lines that will allow us to find points in space. So what is important here? You need to remember the following. You need to label these axes with arrowheads and with their correct names, x and y. You need to label the axes points with the correct scale, and you need to understand that these have to be the same distance always so that you get a proper grid. And you need to label the origin. These are the important aspects that every single one of your drawings has to have. Having created a Cartesian plane, you are now able to properly label where a point is. Much like an address on a GPS, we've got our horizontal and verticals. We need to label it with two important numbers. So let's pick a point. I'm going to pick this point over here, and let me call this point A. That point A has an address, and the address we read starting from the origin, and we start alphabetically or we start horizontally. To get to that point A, we would first travel across here up to the point 4, and then up to the point 2. So the address for A is the point 4, which is its x address, and the point 2, which is its y address. That is what we describe as a point on the Cartesian plane. We have 2 points separated by a semicolon, and that's how we describe a point. You must use the round brackets and the semicolon. So A is 4 and 2. Good, so hopefully you have a setup something similar to this. This is just a little bit of a neater one. And you've got your x and y axes labeled. You should have little arrowheads on the top of them. So let me add my arrowheads in so whoever's reading this knows that these numbers can go on forever. That's good. And they're both labeled. Here's the x and here's the y, as you can see. I want you to plot the following points. I want you to plot A, that is the point 7 and 3. I want you to plot the point B, which is the point 3 and 3. And I want you to plot the point C, which is 3 and 1. Once you've plotted those points, I want you to tell me, where are they? Are they in the first quadrant? Are they in the second quadrant? Are they in the third quadrant? Or are they in the fourth quadrant? Pause this video and draw your sketch and tell me where they are. Okay, good. So you have plotted the points and you've realized that they are in the first quadrant. What we can do when we have points on the Cartesian plane is work out distances. I would like you to try and work out what is the distance from A to B. So what is the distance from A to B? Pause this video and try yourself. Well, how would I get from A to B? A to B is along this line. I haven't had to move up or down, and I can see that with the y coordinates. The y coordinates of both of them is 3. I haven't moved up or down. But what I do notice is that the x coordinates of B is 3, and the x coordinates of A is 7. So how do you get from 3 to 7? Well, you can work out that distance means difference. I'll say it again. Distance means difference. Distance means difference. So if I wanted to work out how far I am, I could work this out using subtraction. I could say that the bigger number, 7, minus the smaller number, 3, gives me 4. So AB would be saying that I had 7 on the x, I took away the 3 where I started, and so therefore I am 4 units away. And your units you'd have to get described in the question. But the distance from A to B would be 4. What about the vertical distance? How far is it from B to C? Pause this video and try yourself. Good. So what we notice is that B and C are aligned vertically. Their x values are the same, but their y values are different this time. And so how would you get, if you haven't moved left or right and you're only moving up, how far up have we moved? We've moved up 1, 2 places. Again, distance means difference. So we could say that 3 minus 1 equals 2. So we could set this up as saying that our ending y value minus our starting y value gives us a distance of 2 units. Another really cool thing we can do is complete shapes on the Cartesian plane. I would like you to put down where is point D. So what are the coordinates of a point called D that would make a shape that is a rectangle? So where would D have to be for this shape to be a rectangle? And the rectangle would be called A, B, C, D. Pause this video, place your point, and give us a label. Excellent. So you found that D is the point 7 and 1, and what we've created is a rectangle. We can use these again to work out different measurements. So let's speak about perimeter first. How would we work out the perimeter of this rectangle? Pause the video and tell me what the perimeter is. All right, good. For perimeter, we need to know distances on the edges. So let's start the distance from A to D. This distance from A to D hasn't changed on the x's, but it has changed on the y's, and it is 2, which means if this is a rectangle, this is also 2. We've worked out already that the distance from A to B was equal to 4, which means that this distance is equal to 4. So our perimeter, in this case, spelling, is equal to 4 plus 2 plus 4 plus 2, which is 6 plus 6, which equals 12 units. What is the area of this shape? Pause the video and tell me what the area is. Area, as you remember, is one edge multiplied by the other edge. So the area of this triangle would be 4 times 2, which equals 8 units squared. Let's stick with our shape that we drew, and let's speak about the concept of reflecting this shape. What happens if I wanted to reflect this shape over the y-axis? Well, first of all, let's identify the y-axis. The y-axis is this line coming down vertically. And if I wanted to reflect something, it would be the equivalent of me placing a mirror here and reflecting this shape. In which quadrant would this shape be reflected into? Would its reflection be in the first quadrant, the second quadrant, the third quadrant, or the fourth quadrant? If I was reflecting over the y-axis, where would the shape be reflected? Pause the video and answer the question. Very good. It is in the second quadrant. I would like you to now plot all of these points as reflections over the y-axis and then answer the question, what is the new point name for A when it is reflected? Pause the video and answer. Excellent. So you would have reflected it over the y-axis, and everything that was in quadrant 1 is now the same height but a different x value in quadrant 2. So this was 3 units away, which means this one is 3 units away. This was 7 units away, which means now it's 7 units away in the other direction, which is why it's negative. This was 3 units away positive, it's now 3 units away negative. This was 7 units away positive, it's now 7 units away negative. The shape has maintained its perimeter and area. It's the identical shape when we reflect it. When I drew a reflection here, I indicated that it was a new point by putting this little prime above each letter. So that little prime means this is the first time I've done something to the originals. What we now see, what about reflecting over the x-axis? I'd like you to answer the question, in which quadrant would this shape be if it was reflected over the x-axis? Very good. It would be reflected into the fourth quadrant. Pause the video and draw the reflection of this shape over the x-axis and give the coordinates of point B. Very good. So you have now given the point B is 3 and minus 3. let me take note of what I've done here in the following. In the previous drawing is 2 primes, which means this is the second time I have manipulated these functions. So b double prime down here is 3 and minus 3. All of the x values stay the same when we reflect on the x-axis. It is only the y values that change their positivity. So plus 3 becomes minus 3, plus 1 becomes minus 1, plus 3 becomes minus 3. When we reflect on the x-axis, it's only the y values that become negative. What would happen if I wanted to reflect this shape first on the x-axis and then on the y-axis? Where would this shape be? In which quadrant would this shape be if I did a double reflection on both axes? Pause the video and answer. Very good. It would be here in the 3rd quadrant. Stop the video, redraw the shape, and tell me what are the coordinates of C when you've done a double reflection over the x and y axis. Okay, very good. What you can see now is I've got 3 primes. This is the 3rd time I've asked you to change this original shape. What do we notice has happened? C is now minus 3, minus 1, when it was positive 3, positive 1. D is minus 7, minus 1, when originally it was positive 7, positive 1. A is minus 7, minus 3, when it was positive 7, negative 3. So a double reflection maintains the size of the points, but just changes their positivity. Everything is now as if it had gone down and across, or down and across. Or we could picture it as if I've gone across and down, across and down. These new coordinates are prime 3 with negatives of the originals. Okay, set up a new set of axes, draw them again, draw the shape, and label the points, point A, point B, point C, and point D, and label them properly. What are the coordinates of these 4 shapes, these 4 points? So what you noticed is that A was at the origin, and its point is 0, 0. D had not moved left and right, it had only moved up, so it had moved up 2 spaces, so therefore it hasn't moved left or right, but it has moved up. B had not moved up or down, it had only moved right, so that's why it's positive 4, and C had moved across and up. It had moved across 4 spaces and up 2 spaces. What I'd like you to now do is reflect this shape on the y-axis and give me the new B coordinate. Okay, so here it is. The shape has been reflected on the y-axis. It is now in quadrant 2, and as you can see, B original was 4 and 0, and this new B is minus 4 and 0. So when you reflect on the y-axis, the x values change their positivity and the y values don't change. It stayed on the x-axis. Okay, so a final recap. Things to remember. We have a space called the origin. From that origin, we can move left and right. If I move left and right, I'm moving on the x-axis, and the x-axis is the horizontal movement. Horizontal always comes first. From the origin, I can also move up and down. Up and down movement is a y value, which is the vertical. It comes second. And what you'll do as a pairing is find out spaces, and each space would be a description of a horizontal movement and a vertical movement. And we can use those to create shapes, work out distances, or work out reflections. These are called ordered pairs, and they will be useful because they can describe spaces for us. Other things we must remember is to label the axes with continuous lines, because they are 2 number lines that intersect at the origin, an x number line and a y number line. Another important thing is to make sure that all of our distances are the same, going left, right, up and down, so we get proper distances. We can't have a football field where one team plays 25 meters and the other team plays 50 meters. Last bit of importance is that all the numbers going over here are positive x values, and all the numbers going over here are the negative x values, and all the numbers going up here are positive y values, and all the numbers going down here are the negative y values. I hope you've enjoyed this video. I will be posting it to my YouTube channel if you want to watch it at a later stage. Enjoy the questions and enjoy the work today, guys.